Okay, so I promised you guys a video discussing critical values. In step 3 of the 5-step process, you calculate the critical value, you calculate the statistic, the sample statistic, using the z-score formula, or the same formula but substituting for t. And then you need to determine the probability of that statistic. So how likely is it that you obtained that sample statistic given that population mean? So you subtract the population mean, so the population that you're comparing your sample statistic to, you subtract the population mean from the sample mean and then divide by the standard error to get the sample statistic. You then need to determine the probability of that sample statistic, and if that probability is less than the alpha level, then you reject the null hypothesis. So if you're using an alpha level of 0.05 and you get a p-value that's less than 0.05, then you reject the null hypothesis. The other way of doing this is just using critical values. So you find the critical value associated with your alpha level, and if your sample statistic is beyond that critical value, then you can also reject the null hypothesis. So you don't actually need to do the probability p-value step. It's just conventional to do so. We use p-values to communicate the outcome of our data, but you can just use critical values instead. So the critical value is the value in a distribution that's associated with a particular alpha level or significance level. So we know that for a two-sided, two-tailed distribution, that's for a non-directional hypothesis, the z-score associated with a 95% confidence interval for a two-tailed distribution is 1.96. So that's the critical value for a two-sided distribution for a 95% confidence interval, or for a alpha level of 0.05 is 1.96. So if you get a z-score that's greater than 1.96 for your sample statistic, then you can reject the null hypothesis. You know that you have a p-value that's less than 0.05 and you can reject the null hypothesis. So on your standard normal tables, which is what I've got here, if you scroll down, you can see that you've got the critical values of the standard normal distribution here. You can see they're different, as we know, for one-sided and two-sided, or two-sided distributions. So one-sided is for directional hypotheses, two-sided is for non-directional hypotheses, and they are also different for the different alpha levels. So this is at 0.1, so this is for a 90% confidence interval. This is 0.05, so this is when you're using 95% confidence intervals, and this is 0.01, so that's when you're using a 99% confidence interval. So you just need to figure out whether your hypothesis is one-sided or two-sided and what alpha level you are using, and then you locate that critical value, and if your sample statistic is greater than that critical value, then you can reject alpha. You can reject the null hypothesis. Now, you do the same with the t-distribution. So with the t-distribution, you don't have one distribution regardless of sample size. You have a different distribution for a different sample size. So you need to determine the sample size, or the degrees of freedom, which is represented here by a v. And again, you need to determine the alpha level. So if you have a sample size of 30, then you subtract 1 to get 29, the degrees of freedom of 29. If you have an alpha level of 0.05, you go, okay, here's 29 and 0.05. If I have a t statistic that's greater than 1.699, then I can reject my null hypothesis. Okay, so you've got a different alpha level. You've got a different critical value depending on the sample size. So you need to consult your table to determine what your critical values will be. And then same with the chi-square distribution. It's the same idea. So here's your alpha levels here, here's your degrees of freedom down the side. So you need to determine your degrees of freedom and consult the critical value table.